Welcome to our smart home presentation. We will explore innovative solutions for home security, and weather prediction and access control. Ultimate develop a cutting-edge system to make your home safer and more intelligent. And this is our innovative team. We have Fufam, who's a lead developer in specializing AI and machine learning algorithm. And next is Gio from a hardware engineer focusing on sensor integration and IoT device, which is me. Next is Longchan, software architect design robust and scalable smart home system. Why would you use a smart home technology and why it matter? Because first it enhance security. Smart home system provide advanced security feature, like advanced system feature that will protecting your property and loved one for potential threat. Next, it improve comfort, automated system that predict model enhance daily living by anticipating need and adjust the environmental change. Next is seamless access. Only those who are supposed to have access are allowed while minimize the inconvenience for the authorized user. Increasing the property value. Home like smart home equipped with smart technology often have higher resale and are more attractive to potential buyer. And for the project overview, right? We will start with three parts: the intrusion detection system, the rainfall model, and the password door. For the intrusion detection system, right? Imagine a home that actively watch over itself, detecting threat in real time using AI power technology. This system ensures that power stay safe, instant alert, and intelligent monitoring. Next is rainfall prediction model. Plan your day and manage your home better with our advanced weather prediction system using sensor data and machine learning. It forecasts rainfall at impressive accuracy, enhance your convenience and efficiency. Next is password control door system. Say goodbye to your lost key and hello to security and customer access. Additional locking system would integrate seamlessly with your smart home for an added layer of security and ease. Now let's start by dividing into intrusion detection system and see how it works.
About the intrusion detection system. The input image captured from the camera will continuously send to the computer that equips UVA detection. The output is the detection images that have the bounding block outside the object like laptop, bottle, person, chair here. After that, the images will go through the intruder detection algorithm to get a warning intruder and the red light bounding block if the person in the frame. If not, they are the same between the detection images and the output images here. In the real-life application, if we have the signal as visualized in the red box here, we can trigger a lot of system like the homeowner's smartphone to give a warning if there are a stranger that's outside and close to their home, and to help them have the protections planning for this warning. Uh, Next, I will give a demo here. If I am in the frame, the warning in the button box here, but when I go outside, it will disappear. And when I go inside, immediately it will trigger a signal here. So the camera in here, and we have the laptop that's equipped with yellow VA and the intruder detection system. So I get my phone as camera, and this will connect with my laptop here. So it's the demo when I was in the library at night. Next is the rainfall prediction model. So if we want to predict from the input to the output, we can The best way as for the reason is machine learning in this case. So we choose to use machine learning. However, uh, the machine learning need the data. So we need to collect the data here. And the measurement input is the temperatures and the humidity. So the data here is need to contain the temperature and humidity, with the label is the status of rain. Rain is the yes or no. And in the practical application, it will have the homeowner to plan activity or manage a irrigation system efficiently, or mm, this will help the homeowner to automatically close the curtain and the window and the door when it's rain before it's rain. Fixing model. The first one is the data repairing and classifier training. After that, we will use the best classifier is the retrain model for inference from the inputs. We see the temperature and humidity from the sensor, and we will get the associated reductions of rain. So in practical application, it will help the homeowners to plan activities and manage smart irrigation systems efficiently. First, this is the dataset preparations. We will get the dataset from many locations across the Bangladesh in 10 years from 2013 to 2022. At the table here, we can see that the temperature at the temperature 0, humidity, and the label if it rained at this time, it will assign to yes, and the other white is no here. And next step is the data reprocessing process, because we want to train the model, and evaluation is if this algorithm is good or not. We need to validation on the validation set dataset, so we need to split into two sets of data, but ensure that the distributions of training set and validation set are the same, and they are the same with all the set here. And we can see the number of brands yes or no here is the imbalance. So to measure the efficiency of algorithm, we need to use F1 score instead of accuracy. So we go to classifier training, retraining dataset, and evaluations on validation datasets, and get some number here. We use many algorithms like logistic regression, KNN, decision trees, support vector classifier, random forest, and the example algorithm using the majority voting policy of 5 rivers algorithm. And we observe that KNN achieves the certain F1 score on validation dataset, so we choose KNN model as classifier in this system. And we to the prediction inference step. We use the sensor DHT20 with the temperature and humidity reading from them is visualized in the image here. The temperatures are variety from 26 to 27 and humidity range from 60% to 70% here. And with this measurement, we get the rain prediction is 0. This means there is no rain between the time step 0 to 40. And actually at this time there is no rain. So this algorithm is right in this case.
So next, I will introduce the password control door system with 4 key features. The first one is secure access. The 4-character passwords provide a balance between security and ease of use, protecting against unauthorized entry. The second is customizable password. User can change the password by pressing a sharp and entering a new combination of password, allowing for personalized and updatable security. The third is feedback mechanisms. With the LCD display and the buzzer, provide a clear visual and auditory cues, enhancing user interaction and system transparency. The final feature is ultimate door control. The DC motor automatically operates the door upon successful password entry, offering convenient and seamless integration with the home environment. The password control door system has 3 main components, 5 main components. Arduino Uno R3 for the main controller for the system, 3x4 keypad for password input and to change passwords. The LCD display for show the system status and message like wrong password or correct password. The DC motor for operate the door mechanism, and the buzzer for generate audio alert for successful or failed access attempt. The first component of the system is Arduino Uno R3, which is a popular and widely used microcontroller board in the Arduino ecosystem. Known for its versatility and ease of use, here's an overview of its specification and features. We choose the Arduino because it's easy programming with the Arduino IDE supports numerous open source libraries and examples, large user community and extensive support, low cost and readily available, and widely used in electronic automation and control projects like this. The next component is the LCD display. We choose the LCD 1602, which means it can display the 16 characters per row on 2 rows. It is often paired with microcontroller like Arduino to display text, numbers, or basic custom characters. For the interface, I use the 12C module to reduce the pin usage. The main function is display system status and user prompt. The next component is 3x4 keypad. The keypad features a 3x4 matrix layout comprising the 12 buttons 0 to 9 plus star and sharp button. Its primary function is for password input for secure access, and it also facilitates system control functionalities such as password change. The next part is a DC motor. We use a 12-volt DC gear motor for door operations. It controls and managed by Arduino 2 motor drivers. Its main function is open and close the door automatically. The final component is the buzzer. It provides the audio feedback for failed access attempts. Its technical specification is operating voltage is from 3.5 to 5.5 volt. Current consumption is less than 25 millimeter ampere. The frequency is about 2300 Hz and the sound level is greater than 80 decibel. So how did the door system operate? So first we enter the password. User input the 4-character code on the keypad. The second part is verification. The system checks the entered passwords against the stored code, which is 1234 as the default password. So for the feedback, the LCD displays status, the buzzer sound for failure, and the final is the DC motor activate to unlock the door if password is correct. The system had some security features. The first one is password protection with 4-digit code for access. The second is wrong password alert. The buzzer sound on for incorrect password attempt, and attempt tracking for count incorrect password entries. The final is customizable setting with changeable passwords for enhanced security. So here is the simulation of the system on Proteus. When the system is on, the LCD displays will appear enter passwords and we press 1234 as the default password and is accepted, and the DC motor will open the door. So for the incorrect passwords, we will press 1256 and with LCD appear a wrong password and the buzzer will alert. So for change the password, we press the sharp, which is the Hui in this keypad. We press the current password and change the password to 1046. So when we press the old password, is appear is wrong password and the buzzer will alert. So when we press the new password with it 1046, password is accepted and the motor will open the door. The advantage of this system is convenient because we no need for physical keys and easy access with passwords. We also have enhanced security with customizable passwords and wrong attempt alert with the buzzer. And this system is very cost effective because it's a readily available and affordable component. So it also have the flexibility when it's easily adaptable for various door type and setting with the DC motor. With the advantages, the system also have its limitation. The first one is power dependencies because it requires constant power supply for it to work. The second one is the technical issue because the program we make might not be optimized, so it may lead to potential software glitch and bug. And the final is the physical vulnerability, because component may be prone to damage because it's affordable and cheap, so it don't have something outside to protect itself. At first we just came up with the security door system, and in the end we end up making 3 different systems. But for the future enhancement, we will make it integration with each other. We will make an app to control and monitoring the 3 subsystems. We will add more subsystems like automatic window system and watering system to integrate with the weather prediction system. We will also expand the weather prediction by incorporate more environmental sensor and detailed microclimate forecasting. And we will use biometric access control for the door system, like upgrading door system with fingerprint and facial recognition option. So this is the end of our presentation. So thank you for watching and listening to our presentation.